Good morning. Welcome to example 3 of locate centroid. So the centroid, we're looking for the centroid of this composite figure. Due to the limitations what I have with what I'm using, we're looking, normally we would be looking for the centroid of the shaded area. I haven't really figured out how to shade that big triangle or the big rectangle with the circle cut out. So we are locating the centroid of the non-shaded area in this problem. The typical problem would be locate the centroid of the shaded area. But I haven't figured that out yet. So non-shaded portion, locate the centroid of the non-shaded portion. So this is going to be a subtraction problem. All right, so we'll take the area of the rectangle and subtract the area of the circle. All right, because we're not interested, the circle, it's kind of like the deck problem I talked about in the first video, right? So, all right, so first step, identify the X and Y axis because our measurements are in reference to the origin. So we've got that. So let's get our chart set up. So let's see, we said we needed an area, X bar, Y bar, area times X bar, area times Y bar. I'm going to call shape 1 the rectangle. Area of a rectangle, looking at the table, if you don't know, we can look at the table, it says length times width. I think it actually uses base times height. But... All right, so our rectangle is, let's see, it's 150 plus 200, so that's 350 millimeters. And then 300 plus 200 is 500 millimeters. If we multiply those together, 3 zeros, 5, 1750. So that equals 175, 1, 2, 3 zeros millimeters squared. So for shape 1. 1, 2, 3 millimeters squared. All right, shape 2 is the circle. So the area of a circle is pi times the radius squared. Pi times the radius squared. So we'll use 3.14, and the radius is given as 100 millimeters. So 3.14, 13. So let's see, 3.14 times 100 is 314 times another 100. Yeah, 31,400. I feel like I should have been able to do that without the calculator. 31,400 millimeters squared. 31,400 millimeters squared. All right, and that's going to be negative because we are subtracting that away from the rectangle. So that is negative because we're subtracting it away from the rectangle. All right, we need to get X bar. So X bar, remember, is the horizontal distance of the centroid for the individual shape. So our first one is rectangle. So that's half the distance from the origin to the outer edge. B over 2 is what our table shows on page 454. So that's 350 divided by 2, 175 millimeters. And it's also halfway up, so 250 millimeters up. All right, now for the circle says it's the diameter divided by 2. The diameter divided by 2. Well, that would be the radius, right? Now, so the radius is 100, but I've also got to, so I've got to start at the origin though. So to get to the radius from the origin, I go 150. Right, so that's the radius, 100, plus this little 50 millimeter piece here. So 150. To find the y bar, it says diameter divided by 2 as well, except I've got to go up to get there, right? So the distance from the origin up to that center is 300, right? So it's, the radius is 100, radius is 100, plus the distance it takes for me to get to the circle, which would be 300 total. 300 millimeters. All right. It's multiplication after that, right? This is the part that most of us like doing. We've done all the hard work already. So 175,000 times 175. That's a very large number. That's a 30,625,000 cubic millimeters, and 175,000 times 250 millimeters, even larger number, 43,750,000 cubic millimeters. I think I have too many zeros. That doesn't look right. Yep. Cubic millimeters. Okay. Now, don't forget we're pulling out or subtracting the circle from this. So the area we said was negative. So that's going to make our AX bar and our AY bar negative. 31400 times 150. So that's negative 4,710,000 millimeters cubed. And then area times 300 doubles it, right? Yep. I knew it's going to double it because 300 is double 150. 9420123 cubic millimeters. All right. So now we do our additions. Someone once asked, why do I make these big old boxes here? I don't know. I think it's just one of those things that keeps me organized. All right, 175,000 minus 31,400. Oh, you guessed it. 143,600. 143,600 cubic millimeters. 30625,123 minus 4710123. What did I get? I'm sorry. 25,000. 25 million. 25,915,000 cubic millimeters. And finally, the last one, 43750,123 minus 942,1123. And I got 34 million. 34,330,000 cubic millimeters. Okay. All right. So now we're looking for the big X. So the big X, remember, is the summation of A little x bar divided by summation area. So 2591500 cubic millimeters divided by the summation area, 143,600 square millimeters. I'm still here, don't worry. Let's see, so I get 180.47 millimeters, and then y bar summation of the area, little y bar divided by summation area. That was 3433000 cubic millimeters divided by 143,600 millimeters squared, and we get 239.07. Okay, so what does that mean? That means that the centroid for this object, and so the object that we're looking at is the non-shaded portion. So get different colors so we can use green. All right, so 180, so that's got to be past 150. So we'll call it like probably right around here, and then up 239. So that's 200. So what would that be? 239 would be in the circle, right? Because that would be 200. So if I'm at 180, probably like right in here. Right, because this would be 200 would be to the outer edge. I need to go 180. Yeah, so I would say it was about right there. How do I want to? So that's the centroid. So that should make sense, right? Normally it would have been in the middle. So the exact middle would have been at 250, 175. But because I've got some material out, that would shift it over. So in my head, that makes sense. All right, let me go review our steps real quick. Step one was to identify the X and the Y. Yep. Step two was the area. Step three was the small X and Y bars. Step four was the multiplication step. Step five was summation of the areas. Step six was the summation of the A and X and Y bars. I feel like I left a step out somewhere. Step seven was do the arithmetic, and step 8 was draw it on the drawing. Must have combined a step somewhere. Okay, so third example. Hope you guys having a great day. Please make a comment in the comment section on YouTube. Let me know if the video is helpful or not. Talk to you later. Bye-bye.